This video is for section 1.6. This will be the first part. We're going to name polygons. This is a review, the definition of a polygon. Recall that a polygon is a closed figure in a plane formed by segments called sides. A polygon is named by the number of its sides or angles. So let's talk about that definition for a second. It talks about it being a closed figure. So this particular figure right here is not closed, so that would not be a polygon. Also, a polygon has to be a plane figure, meaning it has to exist on a plane. So any figure that would not live on a plane, like this solid figure, that's a three-dimensional object, that's not going to live on a plane. So that green figure there, that's not a polygon. Also, the polygon has to be formed with segments. So this figure right here is not a polygon because that last piece right there is not a segment, that's a curve. Okay, so those three examples with those colors, red, green, blue, those are not polygons. Okay, well, what is a polygon? Well, the first polygon that you're going to see is a triangle. It's closed. The sides are segments. It's not three-dimensional. Quadrilaterals have four sides, so maybe something like that. Now, there's lots of different types of quadrilaterals. We actually have an entire chapter on that we're going to look at later in the year. But anything that has four sides is a quadrilateral. Pentagons have five sides, so on and so forth. Hexagons have six. Heptagons have seven, octagons have eight, nonagons have nine, decagons have 10. There are 11-sided polygons, and they have a name. It's called a hendecagon, but we're just going to call an 11-sided figure an 11gon. A 12-sided figure, that's a dodecagon, but we're just going to call it a 12gon, just for simplicity's sake. You guys just have to be aware of these 8 prefixes. Anything after 10, we're just going to use the number and then gon after it to refer to it. So you can have a shape with 100 sides. That would be called a 100gon. Now, there actually is a prefix for that, and we'll talk about that at some point, but we're not going to focus on it for the rest of the year. You're not going to have to memorize those. Just have to know those 8. Okay, so here's a review. This is a polygon. This particular polygon has 6 sides and 6 vertices. This is a hexagon. So I talked about 6 vertices. That's plural for vertex. A vertex is a point of intersection of 2 sides. For example, that point P that the arrow is pointing at, that's a vertex. Consecutive vertices are vertices that are next to each other. Another way to think about it is they are 2 endpoints of any side. So again, notice where the arrows are pointing there. Point Q and point R are consecutive vertices. They're next to each other. They're endpoints of a side. Consecutive sides are sides that share a vertex. So again, look at the arrows. We have a green segment here and a green segment here. Those are considered consecutive sides because they have point S in common. Segment RS and segment TS share point S. Notice how they have S in both. Those are consecutive sides. Diagonals connect non-consecutive vertices. So that purplish segment right there, that's a diagonal. You have 3 diagonals coming from each vertex on a hexagon. So we'll go to point Q and draw its diagonals. We'll do the same thing for point R and point S. So if you draw all of those diagonals on there, it makes a cool little design. Here's some definitions. The first one we're going to talk about is equilateral. Polygons that are equilateral have all sides congruent. Here's a good example. Make these marks. That's a shape that is equilateral because all of the sides are the same length. Now, if you notice this middle shape, the top segment is way longer than the segment on the left. So that's not equilateral. Equiangular, that's a tough word to say, but equiangular just means all of the angles are the same. So if you look at this shape, I tried my best to make sure these angles looked like they were the same. So that middle shape is an equiangular polygon. But this first one definitely is not. If you look at it, that bottom angle with one arc is acute, and the angle with two arcs on top is obtuse. They can't be the same. So you can have polygons that are equilateral but not equiangular, and vice versa. That middle guy's equiangular but not equilateral. Okay? Now it is also possible that both the sides and the angles could all match. If that happens, the figure is called regular. So regular polygons look like this. All of my sides are the same. All of my angles are the same.